Over the last few videos, we've built up a kind of robust toolkit for using implicit differentiation to solve various complex equations with x's and y's interspersed throughout it. And now let's see if we can go back to the question that we opened up the topic with and see if we've got enough intelligence under our belt to make sense of it. So our original problem was dealing with the curve 2x cubed plus 2y cubed is equal to 9x squared. And our point we were interested in finding the derivative at was 2 comma 1. Okay, so let's start out with 2x cubed plus 2y cubed is equal to 9xy. And we want to take the derivative of both sides of this equation with respect to x. Over here, we've got two terms. So the derivative of 2x cubed with respect to x, that's going to feel familiar to us. That's just a matter of using the power rule and the constant multiplier rule, constant coefficient rule. So 2x cubed, the derivative of that with respect to x is going to be 6x squared. All right, how about our next term, 2y cubed? So here, we've just got a y by itself. So we can think of this as using the chain rule, or we can just think of it in a kludgy way that we're going to take the derivative with respect to y. So that's going to be 6y squared. And that was the derivative with respect to y, so we need to multiply that by the derivative of y with respect to x. Okay, so that takes care of the left-hand side of the equation. Now over on the right-hand side, we've got 9 times x and y. So remember in the last video when we came across this where we were multiplying x and y together, we really needed to use the power rule in order to take the derivative here. Okay, so this was equal to, well, let's separate out the 9 first, and then we'll take the derivative of xy. So using the power rule, it's x times the derivative of y, and the derivative of y is dy dx, plus the derivative of x times y, and the derivative of x with respect to x is just 1 times y. Okay, so we can think of that as 1y. The derivative with x, the derivative of x with respect to x is the 1, and then it's just the y. So this is the derivative of xy with respect to x. All right, so the calculus part of this problem is done. All we need to do now is some algebra to solve for dy dx. So we've got 6x squared plus 6y squared dy dx is equal to 9x dy dx plus 9y. And maybe the first thing that we can do is we can just divide everything by 3 because all of these terms are multiples of 3. So that's going to be 2x squared plus 2y squared dy dx is equal to 3x dy dx plus 3y. So now, since we want to solve for dy dx, what we should do is get all the terms that have a dy dx as a factor over to one side of the equation and all of the other terms over to the other side. All right, so I'm going to move this term over here. So over here, we're going to have 3y minus 2x squared. And over here, I'm going to move this term over. So I'm going to have 2y squared dy dx minus 3x dy dx. Okay, so this is getting kind of close. Each one of these terms has a factor of dy dx, so I can factor that out. So that's dy dx times 2y squared minus 3x is equal to 3y minus 2x squared. And so finally, dy dx is equal to 3y minus 2x squared over 2y squared minus 3x. Okay? And remember, our goal was to find the slope of this at the point 2 comma 1. So how can we find that slope using this formula? Well, just everywhere we see an x, we can replace it with a 2, and everywhere we see a y, we can replace it with a 1. So this is equal to 3 times 1 minus 2 times 2 squared, which is 3 minus 8, over 2 times y squared, which is 2, minus 6, which is equal to negative 5 over negative 4, which is equal to 5 over 4.